In the diagram, BCDE and AODE are parallelograms. A, prove that OF is parallel to AB. B, prove that ABOE is a parallelogram. And C, prove that triangle ABO is congruent to triangle EOD. Let's start with part A. Prove that OF is parallel to AB. Let's mark OF and AB in red. We have said in previous videos that if you are given two sides that are different lengths and asked to prove they are parallel, there's a very high chance you will need to use the midpoint theorem. This diagram may not be to scale, but we can easily see that OF is not the same length as AB. So let's look at midpoints. O and B lie on the line BOD, so let's make it green. F and A lie on the line AFD, so let's make it green as well. If OF is parallel to AB, then O must be the midpoint of BD, and F must be the midpoint of AD. So now we need to try and prove this. The only information the question has given us is that BCDE and AODE are parallelograms. So let's see if we can use the characteristics of these parallelograms to help us. Let's start with BCDE, and we can make it purple. Now we can see that BOD is a diagonal in parallelogram BCDE, and we know that diagonals bisect, which means that BO is the same length as OD. So we can make a note, and we can say that BO is equal to OD. Because the diagonals of parallelogram BCDE bisect, let's put a small blue line on BO and a small blue line on OD to show that they are equal in length. Now let's take the purple parallelogram out of our diagram. Next, we need to prove that F is the midpoint of AD. So let's see what information we can get from the characteristics of parallelogram AODE. Let's make this parallelogram purple. AD is a diagonal of the parallelogram, and we know that diagonals bisect each other. So we can see that AF is the same length as FD. So now we can make a note. We can say that AF is equal to FD. And as our reason, we say the diagonals of parallelogram AODE bisect. Let's put two small blue lines on AF and two on FD to show that they are equal in length. Now we've proven that BO is the same length as OD and that AF is the same length as FD, which means that O is the midpoint of BD and F is the midpoint of AD. So we now know that OF is parallel to AB according to the midpoint theorem. Let's put a small blue arrow on OF and again on AB to show that these lines are parallel. Prove that ABOE is a parallelogram. Let's make ABOE red. To prove that quadrilateral is a parallelogram, we can prove that both pairs of opposite sides are equal, or both pairs of opposite sides are parallel, or both pairs of opposite angles are equal, or the diagonals bisect, or that one pair of opposite sides are equal and parallel. We know that OF is parallel to AB because we proved this in part A. So to prove that ABOE is a parallelogram, let's try and prove that AB is parallel to OE. Then we need to prove that AB is also equal to OE, or we need to prove that BO is parallel to AE. So let's make some space. Now we can make a note that OF is parallel to AB. We don't need to prove this again, so we use proven above as our reason. Let's look at the characteristics of the two parallelograms the question has given us to help us find more information about ABOE. Let's start with parallelogram AODE. Let's make it purple. OE is a diagonal in AODE, which means that it's a straight line. So we can make a note that OFE is a straight line because it's a diagonal in parallelogram AODE. This means that if OF is parallel to AB, then we can see that OE is also parallel to AB. Now in ABOE, we have one pair of opposite sides that are parallel. So let's see if we can find another pair. AE lies in ABOE and it lies in parallelogram AODE. So we can see that AE is parallel to OD. And as our reason, we say the opposite sides of parallelogram AODE are parallel. Let's put two small arrows on AE and two arrows on OD to show that they are parallel. But we don't want to prove that AE is parallel to OD. We want to prove that AE is parallel to BO, the opposite side of ABOE. So what else do we have to work with? Let's make AODE black again. We know from the question that BCDE is also a parallelogram. So let's make it green again. OB is a diagonal in BCDE, which means that BOD is a straight line. So let's make a note that BOD is a straight line because it is a diagonal on parallelogram BCDE. Now we can see that if AE is parallel to OD, it must be parallel to BO, the other side of the straight line BOD. So we can see that BO is parallel to AE. Now we've proven that ABOE has two pairs of parallel sides. So as our answer, we can say ABOE is a parallelogram because both pairs of opposite sides are parallel. Prove that triangle ABO is congruent to triangle EOD. Let's make triangle ABO green and triangle EOD purple. To prove that two triangles are congruent, we need to prove that three pairs of corresponding sides or angles are equal. From the diagram, we can see that BO lies on triangle ABO, and we can see that OD lies on triangle EOD. These lines are equal, so we can make a note that BO is equal to OD. We proved this in part A, so as our reason, we say proven above. Now the question tells us that BCDE and AODE are parallelograms, and in part B, we proved that ABOE is also a parallelogram. So let's see if we can find any more equal pairs of sides. Let's start with parallelogram AODE. Let's make it red. We can see that AO lies in triangle ABO and the opposite side ED lies in triangle EOD. So we can use this and we can say that AO is equal to ED. And as our reason, because these are the opposite sides of parallelogram AODE, which are equal. On our diagram, let's put a red line on AO and a red line on ED to show that they are equal. And now we can take the parallelogram out of the diagram. In our triangles, we now have two pairs of corresponding sides that are equal. So to prove congruency, we need to prove that a third pair of sides or an included angle are equal. In part B, we proved that ABOE is a parallelogram. So let's make it red. AB sits in triangle ABO, and the opposite side EO sits in triangle EOD. We know that the opposite sides of a parallelogram are equal. So now we can say that AB is equal to EO. And as our reason, it is because the opposite sides of parallelogram ABOE are equal. Now in our triangles, we have three pairs of corresponding sides that are equal. So we have proven congruency. And as our final answer, we can say that triangle ABO is congruent to triangle EOD because three pairs of sides are equal. So as our reason, we use SSS for side, side, side.